Okay, so hello and welcome. I think we're back again here. Let me see something. Yes, okay, looks like we're in good shape. So, hello. We're going to try another problem here. I believe I think my volume is set appropriately, so it should be audible. Alright, yeah. So let's get right to it. The question we're going to look at now is number 361 on LeetCode, bomb enemy. Okay, it's an interesting name. Let's see how we do. Okay. Nice, we're engaging in warfare here. Max killed enemies is our function name. Awesome. Great. Alright, so let's see how we do. We want to... Oh, actually, we might modify this. I may remove that. Okay. So the question is, given a 2D grid, each cell is either a wall, W, an enemy, E, or empty, 0, the number 0. Return or the character 0. Really, these are all characters, because these are all characters. Excuse me. Return the maximum enemies you can kill using one bomb. Excuse me, the bomb kills all the enemies in the same row and column from the planted point until it hits the wall, since the wall is too strong to be destroyed. You can only put the bomb at an empty cell. Okay. Placing a bomb at 1-1 kills 3 enemies. Alright, they don't really give a... Hi, hey, welcome back, Garby. Hello. Welcome. Hello. They don't really give us too much of an idea with regard to, like, what the expected runtime should be. So, we can do this in cubic time, where we visit every 0, place a bomb there, and calculate if it went off, what we pick up in each direction. We actually could probably optimize this a little bit, because we can break the contributions of... Basically, we can group rows, split them by the walls, and same thing, columns can be split by walls, and then use a kind of a hash map, I guess, or just a, like, it's kind of a data structure to figure out what the contribution would be. You know, because you have a certain row and a certain column, and that position in that, you know, for a particular row, depending on where the column is in that, on that row, you know, there's a certain amount, and the bomb goes all the way in every direction, horizontally and vertically. So yeah. So there's like a pre-processing step that we can do row by row, column by column. That would take quadratic time, and then that would basically, I would want to figure out a way to actually, you could even do actually, you could do this even better than that. You can do... You ready for this? I have an idea. Okay. Build a summation row by row first, which accumulates number of enemies between walls. I have an idea. So this has got to be quadratic anyway. I have an idea. I think I got it, actually. I think we're in good shape. going to say we're also assuming this is a non-empty grid. So, what we're going to do is say you have an int for each row, count starts off at 0. We say if grid of row column is equal to an enemy, then we're going to increment the count. And we're going to write to our total row column count. Right? We're actually going to increment. And this is going to be, oh yeah, the reason we did this is the number of rows, and these are going to be vectors of integers of the number of columns, and initially 0, right? So we update these to count initially, and then if a wall, set the count back to 0. Right, so we do this, and then we also accumulate enemies, and the bombs will hit column by column. So now you reverse this, you say column, or actually, let's do it this way. Now we're going to say, if it's an enemy, increment the count. If it's a wall, set the count to 0, and continue. And otherwise we're going to increment by the count again. And the only issue here is, do you end up double counting? There's one small problem. Do column, so row by row, that's the number of enemies the bomb will kill in that particular spot for the number for the row, and then now you increase that by the number of enemies that it'll kill. So actually, you really want 2 enemies. You really want a pair, I think. You don't really want. Yeah, you actually want a pair, I think. Let's do a pair. Makes more sense to use a pair. I was thinking about doing something kind of clever, but it's Just grid pair, we'll say. Yeah, I was thinking about doing something kind of clever, but ended up not being ended up not being that clever. Oh, how do I? Huh. Interesting. We'll just leave it there for now on one line. Yeah, so actually I did this wrong. Never mind. No, I was right the first time. I'm sorry. I'm kind of getting ahead of myself. It doesn't need to be. I'm sorry. Let's go all the way back. I had the right idea initially. Okay. So what you do is you get all the you get all the enemies up to a wall, and then you say while loop, and loop backwards of row until you hit a wall, really. And then what you're going to do is once you hit the wall, you're going to, you don't set the count to 0 yet. You do the following. So what you did up to this point is you counted the number of enemies in that particular row. You hit this wall, and now you're going to write all the enemies until you get to the back, or so while row is greater than 0 and grid row column is not equal to W. This is what you do. You do another for loop here. And then you take row minus minus, and you're going to decrement the row. And you're going to say grid, or you're going to say total of row column plus equals count. That's what you want to do. And then you're going to set the count equal to 0. And then you're going to set row equal to I'm going to say temp is going to be the row and equals t plus 1. Right, and scroll past this wall now. That's what you want to do. So I was actually correct initially. I had the right idea. I had somewhat of the right idea. I just didn't implement it correctly. Let's actually take this inner portion is basically the same. And I'll re-chat in a moment. So column by column. And you can actually slightly modify this. You could say if grid of row column equals O, then you would accumulate, right? You don't have to accumulate everywhere. Same thing here. And now you go column by column, count to 0, increment the row, right? If you see an enemy, increment. If you see the wall, then set this to the column now. And actually this is wrong, this is supposed to be the column, not the row. I did that wrong as well. Yeah, it's the same that you're looping over here. And so actually this one's already set up properly then. And actually, you don't need to increment by the count anymore. You can take the return value, which is 0, and just update this. We can do it this way. It's going to be the count plus what's already there. And I think that's it. I think that's all you got to do. Something like this. And it's wrong. Nice. Nice. Really? What? Come on, man. You're kidding. What? So the first row, what does this look like? Okay. First row, we go left to right and get this count. Oh, right, I missed something here. Was it or the column is greater than number of columns, in which case we decrement the column. Or greater than or equal to. Yeah, I messed up. Yeah, I made a mistake. Still wrong though. So we should get ones written to these spots. One's here, and then a one. This is a one here, and then these are all zeros, right? And then here we have these all should be ones in our total grid column or row column. And then we would say when we get over here, we go now we gotta start going column by column. Our row would be, this is already a 1. Oh, I made a mistake, didn't I? I did. Yeah, I made a mistake. Yeah. Okay. Anyway, I had the right idea initially. Let's try to be clever again. Just 3 loops, and we should be on our way. I like to go row by column. So row, column, and we just have if this is the case, whoops. And ret equals standard max of ret and total of ret, oops, row, column. Yeah, I'll rechat in a moment. What? Got one, we need three. What do you mean? What? These all get ones. And then, so this is 1, 1, 1, 0. This is 1, and this doesn't get you anything, or it's just all 1, all zeros. This is a 1, 1, a 1, and then here you get, it becomes 2, 2. This was a 1, it becomes 3, and then these become still a 1, and this actually is a 2 now. And yeah, and you go kind of down and up, down and back, right? So we go right to left, right to left, right to left, and then down, up, down, up, down, up, down, up, like that. And how does this not work? What happened? Your cam freezes. Oh, thank you. Thank you. There we go. Oh, let's try this. Stop it freezing onto me. There we go. Hey. Let's see. Read the problem again? Sure. I think maybe you understand it though. Maybe you get it. Put a bomb somewhere and it kills as many enemies as you can, and it doesn't go through the walls. And you can't place it where enemies are, only where the empty slots are. And DP solution in my head. How many left? How many top? How many right, how many bottom, turn the maximum, enemy set the right of its left to 0, and the left of its right set to 0, and so on, a wall, sorry, not enemy. Downside, you have to do 3 passes at most, you can't freezes. I have to think about your solution a little bit more. I gotta think about it. It's probably not wrong. I mean, this is not a very difficult question, it's just, I'm kind of getting destroyed by it for whatever reason. How long is it? It's been 20 minutes? For some reason, why is my solution wrong though? Alright, this is what we're going to do. We're going to debuggery. What does this give us? Debuggery. What? All zeros? Is that a joke? Oh, they have a debugger. I didn't know that. That's kind of neat. We are going to debugger. After the first pass, and after the second pass. Let us debugger. Oh, we really don't need this, do we? Should get rid of that. debug. Debugger, debug. So the first pass does not do what I was expecting it to do. And why not? The first pass only set a 1 here. Literally just here. What? Alright, well I was not expecting that. Count to 0. Increment the count if you see an E, which it should not be. And you don't see a W. And columns not greater than the number of columns. So increment column. Now you should see an E here. Does this ever get called? It does, 3 times. 1, 2, 3. Yeah, it should. Technically there should be a 4th, but I'm not really worried about that right now. Okay. So increment the count. And then what? Okay. Well, eventually we should get here, right? Let's see, what do we get here? Row 1, C2. Oh no. What? Oh, that's why. Oh. That's my mistake. I'm too careful with my loops. Too careful with my loops. Much too careful with my loops. There we go. That's a very subtle mistake. That's an extremely subtle mistake. I'm waiting to go off the side of the map here in order to start going back, to trace back. However, I'll never go off the side of the map because it ends before you go off the side of the map. So you're only ever going to get to the last part. But that's fine, you can go to the last part, that's not a big deal. And then execute this afterwards, as long as you count first, right? That's interesting. So let's see if we're correct. Seems to be correct here. There's probably something I missed here. I'm going to go for it though, because I want to go to bed. Yeah, okay. I don't want to spend too much time on this. And here I am saying it's kind of an easy question. Problems in grid are always annoying. There's always a problem with indexing. Yeah, it's true. It's true. What happened here? What? Oh, right. Because we're not over it anymore. That's why. Okay. That's my mistake again. Yeah, it's part of the same problem. But now we're wrong. What happened? And it's actually greater than or equal to 0. No. So that's wrong too. Yeah, issues with indexing, true. True. What did I? Oh. Oh wait. Oh. Wait. What? What? Oh no. What did I do? Uh-oh. 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 Oh no, here I am saying it's easy. Eating those words right now. What did we do? What did I do? Okay. 1010 expected. This is 1011. Uh-oh. See that? That's wrong. I'm supposed to get a 1 here. Now what happened there? How did that happen? I skipped one of the rows. What happened here? So confused. So we run into the wall. Oh, that's why. Oh, that's super awkward. Oh no. Actually, I'm glad we went over this problem. This is preparing for interview or solving problems for fun. A little bit of both. A little bit of both. Part of it's because I sort of have like time to kill. I've got like these projects that I'm working on, but like they're really complicated in terms of all the details involved. So I've got to kind of like go slow. I kind of have to go slowly. And basically, as I'm like learning more about all the complicated details, I'm realizing I don't really have time to do very much during the day, because like most of the day's over by the time I finish work. So I'm kind of like, all right, what do I do with my time and not go crazy here? And I'm like, okay, well, and I'm thinking, okay, well, I can work on interview questions, and it'll be fun, it'll be interesting. And yeah, and these kind of, I mean, these are interview questions, so like obviously it is to help with interviews, because I've always kind of struggled with interviews, like I'm not very particularly good at it, and I like my job, but like I also would like the ability to kind of like go from company to company with relative ease, which right now it's like kind of a challenge. So I don't know. Yeah, it's a mixture of things. It's a mixture of things. Plus, I used to do this a lot. I used to practice a lot because I kept getting turned down by companies, and I was like, man, I was thinking, man, I need to practice a lot. And like problems like this one, where I just kind of get nailed out of nowhere, and it seems really easy, but then all of a sudden it's like, oh no, it's not that easy. Problems like this are extremely challenging for me. So there's that too. You know, I made a mistake here also, by the way. Oh no, I didn't. No, I didn't. I was fine. We're supposed to exit between the walls, right? No, that's fine. And then reset ourselves past the wall, right? Yeah, we really could just take this out altogether and have different logic for both of these. Similar kind of a thing, but yeah, with the wall, it'll actually immediately close this loop. So you do need to subtract the column once, and then the same thing over here for this wall. And this whole thing is kind of simple enough where we really don't need to get too crazy. We can kind of let's just finish this one first. So we would say here, we go back to a wall. Yeah, this is basically, you pretty much, yeah, it doesn't really matter. I mean, this could be basically identical. The only difference is, like, you know what we can do? We don't need to do that. We can actually make this kind of simple. You can make this a Boolean and say convert it to an integer times, and we would say sort of the negation of this, really. So if it's not this, then we would subtract 1. That's kind of what we need to do. And we also want to put this in the right spot. Yeah, it's so similar to the code. It's like almost the same. You gotta handle walls and going off the map slightly differently. It's such a minor thing too, but it makes such a difference. It makes a difference, significant difference. Yeah, there we go. Let me. Okay. Good luck for your career. Thank you. Yeah, thanks. I appreciate that. Thank you. You too. You too. Yeah, I'm very kind of all over the place when it comes to what I'm doing and what I want to do and all of that. I'm like, right now, I have like certain goals. Excuse me, certain goals that have been just like extremely difficult for me to achieve. I don't know if this is right. No. Oh man. I'm getting destroyed by this problem. This is tough. Oh, come on. No. I didn't think about that. If the wall is this part here. This. Oh, my will. But. Really, this is what you want to do. This should be the. Excuse me. I knew that too. I'm kind of rushing because I kind of want to go to bed, but I probably would have got this wrong actually anyway. Even if I were not rushing, I probably still would have gotten the same. Oh, you're kidding me, really? What? No. Actually, this is supposed to be, if it's equal to the wall, subtract 1. Yeah, alright, let's see. I'm afraid to... This is why I'll never get hired. Not never have a job, but this is so bad. You gotta be kidding me, man. What am I doing wrong? What am I doing wrong? I think I know what I'm... No, this should be fine. Why this? This is sort of the same thing too. I want to say this is the problem. This could be it. Well, let's not. What's happening? Yeah, sometimes deleting all your code and starting at the beginning is the best solution. Yeah, sometimes. I don't think that's the problem here. The problem here is I'm just not being very careful. I kind of assumed this would be like a relatively straightforward thing, but the truth is, this is a pretty new algorithm that I'm looking at, where you scroll forward and then scroll back. You know, scroll forward to accumulate and then scroll back to write it, and then jump to the next spot, scroll forward, scroll back. And there's like a lot of kind of edge cases with regard to doing that, and I like pretty regularly don't get all the edge cases, which is like really annoying. I need to be more patient, you know. Really, that's the issue. So the problem here is this should go left to right. So initially we get this row 0, right? The only row. Go to column 0. We don't see E, we see W. We go back before W, and then obviously this is too far back, so we don't even enter this loop. We reset the count to 0, and then we just go to T plus 1 now. That's fine that this is W, and I'm wondering if it's not W and you go over here, if this even matters. It doesn't matter, really, in any case. It doesn't matter. If it's W, you do need to go past it. If it's not W, then this will just take you out of the loop. It doesn't make a difference. So we should go to 1 now. So column goes to 1, and then, or it goes to, yeah, it goes to 1. And we see an E, we increment the count. We don't see these things. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We get all the way to 9, so the count should be 9. And then we get here to n columns minus 1. And we say, okay. We see both of these things. Count is 9. Both of these cases are true. And we say, okay. Decrement the column here, because we're at a wall, which makes sense. And we say, while the column is greater than or equal to 0, and we haven't gotten to a W, decrement the column, which we don't do that until we actually use the column. And then if the grid row column is a 0, we're going to write to our total the count, which should be 9. And we should go all the way back to 0 right at 9. And then set the count to 0. Once we get all the way back down to W, column is greater than or equal to 0, so yeah, we actually see a W there though, so we stop right there. But we write a 9 at that 0. And for some reason it says 8. I'm so annoyed. And this routine shouldn't really do anything. It should just kind of go in the first row, or yeah, column 0, row 0. It really just goes one element at a time and doesn't really write anything. The count's basically always 0. So why is Also, yeah, I have to remember to start using that, to use R and C to not have to type so much. Why is this total not what I'm expecting? Alright, how do we do? Why is this an 8? What do you mean it's an 8? What? What? No. Huh? What do you mean it's an 8? No, it's not. 0, 1, 2, 3, 4, 5. Excuse me, 5. Wait. 0, 1, 2, 3, 4, 4. Oh, 3 twice. Wait. Oh, wait a minute. Did we skip? Oh. Is that why? Because we were at 0, and it's a W. Oh, that's why. Because the column, oh man. Oh, these subtleties are so subtle. Oh boy. You gotta be kidding me with that. That hurts, man. That is painful. It's so subtle. It's so slight. Program language to use day by day. I use quite a few. Alright, hold on. I'm afraid to hit the button. I don't want to test it. I don't want to. There's so many tests to go through. I don't want to test it. Alright, so the idea was fine, but the implementation was really wonky. I had the right idea, it's just, I mean, that was the point. That was the point of the question, to make it wonky with all these walls and kind of variable little things in there that could be wrong, you know, it could cause problem. This is the kind of question you want to ask in an interview, because it gives you a sense of like the candidate, like how careful is the candidate, you know, because they're like all these little details here, like not increment. You want to go back to the W when it's a W because you're going to increment again here, and you want to, if it's a W, you want to move back a slot because you actually, does this really matter? Do we really need to do this? I don't think this matters. I don't know if this even matters. Wait a second. Am I nuts? I don't know if that even matters. Now I'm thinking about it. I don't know if that even matters. No, it does. Why does that matter? Wait, why does that matter? I still don't know why. Because if the W is at the very end, then you're going to exit this loop too early. That's why. Duh. That's why. Right, because you run into a problem. Yeah. Yes. It does matter. The reason is that you're going to exit this loop too early if you hit the W. And if you hit this at the end, you want to write, you might want to write to that spot. So you don't want to decrement. So you need to make it only when it's this case and not necessarily, yeah, which you're never going to write when it's this case. So that matters, right? That's like a slight thing. And then this over here, you want to update to the previous spot because you're going to update to the next spot anyway. And yeah. Oh, wow. Oh boy. By the way, you can slightly optimize the code using this. But yeah, how careful is your candidate? That's, I think, this is the kind of question that would give you an idea. Oh, uh-oh, what did we do? Oh, oops. Yeah, how careful is your candidate? This will give you a sense of how careful they are, because there's so many ways to mess it. It's pretty simple, but it's so many ways to make mistakes. So I do that regularly too. I'm like not the person who would get this right on the first shot. Like I'm just not. For whatever reason, I guess there's too many of these little edge cases. Like I really have to think about that more. Like, you know, the kind of problems that have walls and have these little extra conditions. Like I need more practice. You know, like I really do. To be more disciplined about like, okay, what different edge cases and different test cases can I go through that can cause problems, and why, right? Like I didn't really find out until I went through their test case, their test bed, which I really should be able to like test these things myself, you know, kind of think of all these different edge cases myself, which is pretty bad. It's not good. It's like, really don't like that. I definitely need to think more about the different test cases. But to be fair, this was pretty awkward what happened here. It's kind of an unusual algorithm. Like it's the scroll forward and scroll back and then jump to the next spot and scroll forward, scroll back. It's like kind of reminds me of like parsing. When you're parsing things, it's a similar kind of a thing. But anyway, not too bad. We got it. We got it. Definitely was kind of rough, but we got there. So yeah, let's see. Also the comments. What programming language do you use day to day? Oh yeah, so yeah, I'll answer that question in a second. 90% of the time when I approach a problem, I try to find a recursive solution. Yeah, that's usually pretty nice. If you do recursively, because there's only like a few edge cases, a few base cases you have to work with for recursive solutions. Although this one kind of lends itself to just a simple, what do you call that? Like, technically it's a dynamic programming question, but just a simple iteration through the array twice to gather the information you need for the rows, gather for the actually it's basically a simulation. It's kind of what I did. Simulated if you were to like walk the path that the bombs would take. That's pretty much what it is walk the rows, walk the columns, and update an array of like how many enemies you're going to end up killing. And actually this is made a little bit simpler because you can't put a bomb on top of an enemy. There's actually another slight thing you do. If you could put bombs on top of enemies, every spot that has an enemy, you'd be double counting the bomb there, double counting the enemy there, so you have to actually subtract 1 for each of those. But that's obviously we didn't need to do that for this problem, this question this time around, because you couldn't put bombs there. But yeah, and then at the end you just gather the maximum of all the numbers that you computed, that you counted. Basically, yeah, yeah. So yeah, this one wasn't too bad to not do it recursively, although as we saw, the construction of like actually scrolling forward and then walking, and then scrolling backward basically, and then walking forwards, walking backwards, and then scrolling forward to the right spot. That's tricky. That logic that's always something you can kind of make mistakes doing. So programming languages, I work on algorithmic trading systems for large hedge funds, financial institutions, and I work on specifically. So I was hired as a C++ developer, so I was vetted for my C++ skills. They tested me. Way back when. This was like years ago now, 3 years ago or so, over 3 years ago. It's approaching like 3.5 years. Yeah, years ago they vetted me for my C++ skills. That's what they hired me for initially. And now most of the code that I work with, so I write quite a bit of Python, a lot of the code that I work with is Python, JavaScript, because I work on a front end, a monitoring front end. It's kind of complicated. It has a Python backend, and I do considerable amount of like digging through like Linux, like just kind of using Linux scripts and digging through log files. And the code base itself is largely C++. Like it's a few million lines of C++ code for the actual system, although I tend to work on like ancillary systems, like the monitoring system I work on, which is a little bit different from the main system. And the main system, I've dug through the code a little bit here and there, although I tend not to. There's actually modules that are sort of components that I have spent a little bit of time programming those a little bit in C++, not too much, not too bad. And yeah, there's like Linux scripts, Bash scripts. I've done some work on Perl scripts. Yeah, Python scripts, Perl scripts, Linux scripts, or Bash scripts, C shell scripts, if you're familiar with at all with C shell. It's kind of old. What are some other ones? Done some TSQL as a Mongo database that's used here and there. At one point I was learning about, what's the other database I was learning? I never really got too far into it. Oh, Elasticsearch database, which is kind of interesting. It's got its own query language, its own DSL. Oh, Ruby scripts, right? Plenty of Ruby scripts. I forgot about that. Yeah, quite a bit of Ruby. There's actually one of the monitoring tools is largely built in Ruby. I think it's JRuby backend and then eRuby front end. So eRuby for the front end and JRuby for the back end. So it's Ruby backend, Ruby front end. And the Elasticsearch, a lot of the scripts are Ruby scripts, quite a few of them. So for college I need to learn R, and I'm kind of lazy learning a new language. Yeah, it's not bad. I mean, the language tends not to matter as much as, although actually, so what I've learned is like, the language tends not to matter as much as like, the mind behind it, I guess, because basically just about anything you can do in one language you can do in another language. However, I have noticed over the years of learning different languages. Also, I know Clojure. I don't work in Clojure. I was going to try to build out one of the backends in Clojure, and I was going to convert one of the monitoring tools, the backend to a Clojure backend, and the front end to a Clojure script front end, so it would be Clojure front end and backend. And the reason for that was that I ran into basically, it's not parallelization, it's not synchronization, it's persistence related bugs. So also Clojure's a functional programming language based off of Java, and actually Scala is another language that I could learn more about. Scala if I wanted to. One of the pieces of software that I help, that I monitor. I don't really even look at the source code at all for that. I don't really do very much of the sort of the other work for that either. Not too much here and there, but really very little for the Scala-based programs. But yeah, it's another programming language. I'm not familiar with Scala. However, it's a functional programming language based off of Java. I know Clojure. I've some experience with Clojure, but to learn Scala, it would take me some time. But my point, sorry, is that I've kind of learned a whole bunch of different languages over the years, and kind of worked with a bunch of different stuff. And I would say, yeah, and I've done, different interviewing questions. I've done all kinds of just stuff. I've probably solved like, I don't think I'm at 1,000 yet, but I've solved at least 1,000, or 2,000. Sorry, I don't think I'm at 2,000 interview questions solved yet online, but I know I'm over at least over 1,000. And what I'm trying to say, in a very long-winded way, is more important than the language is like your problem-solving skills, and like what the domain of the problem. Like if you really understand sort of the context of the problem, that's so much more important. If your sort of domain skills related to that particular problem. However, that being said, certain languages are better for certain domains. So Ruby is extremely good for building web applications and building them very quickly. Python's very good for writing scripts very quickly. Linux scripts are obviously great for Linux machines, right? And writing scripts to kind of handle different sort of system-related tasks and automating things. R and Octave, if you're familiar with how to GNU Octave or R, those are extremely good for data processing, data analysis. I haven't really messed around with Octave very much, but I did want to learn. At one point I was interested in machine learning and artificial intelligence, so I was thinking, okay, I'm going to learn Octave and learn, probably not R, but some kind of language that's geared towards data analysis. I think Python has quite a few of data analysis related libraries and whatnot, so I don't really necessarily need to learn Octave. However, yeah, Octave I think would have been pretty good to learn. And similarly, Octave is like MATLAB. It's like a free version of MATLAB. Octave is good, and then I think R is another kind of data analysis language. There's some other stuff too. There's I wanted to write some machine learning, artificial intelligence related libraries, basically rewrite certain implementations for C++ and just kind of put them out there on the internet. And the reason for that was that I wanted to get practice, and I thought, well, just writing some of these algorithms and writing just a C++ implementation of it I would really understand the algorithm after that. It may not be the fastest way to do it, but it would be a reasonable way to do it. Yeah, I'm first year data science student, so I need to offer statistics. Yeah, there you go, right. First year data science, that'll do it. Right. Yeah, a friend of mine is a data science student. Also, I don't know. Oh yeah, he follows the stream. He's a sub. You'll see him every now and then if you watch. He's a pretty sharp guy. He's a pretty smart guy. I definitely appreciate when he comes by and says hello and hangs out and all that. Okay, I should say appreciate conversations with him, exchanges with him. But yeah, that was something I was interested in. There were like a bunch of different machine learning related projects I wanted to put together over the years, but the problem is I have too many other problems to deal with, and I'm like, I don't know when I'm gonna get around to that one day. But there's like a lot of really fun, creative things that you can do with machine learning. That's like it would be really entertaining. Like I wanted to, just say there's things I wanted to put together. But anyway, so. But R is basically data science is statistics. When you learn more about it, you'll realize that. You probably already somewhat realize that, but as you kind of get further into it, it'll become more clear. And yeah, data science is cool. It's interesting. I should say it's interesting. I should say it's interesting. And I don't know R, by the way. I know all these other languages. I've tinkered with all these other languages in one way or another, but R is not something I'm super familiar with. Man, there's so much stuff to do, man. There's just like I'm just thinking about like the things I wanted to do at my job, and I don't know, man. You can only do so much, You can only do so much. Don't get too crazy thinking about it. But anyway, yeah, so that's interesting. First year data science, pretty neat. Problem, a lot of theory and academic about probability. Probability. A lot of theory and academic about probability. Yeah, well that's what statistics is. That's what data science is. Like it's all about probabilities. I would say I don't think it's a problem. I think it's actually really good. Linear algebra, calculus. Yeah, I use those things too, but those are. Yeah, I guess you do need to know those too. Those are kind of minor, though, in my opinion. Like, yeah, I don't know. I mean, it's a mix. It's a mix of all those things: statistics, linear algebra, calculus. It's basically like you can kind of simplify what data science is. It's a combination of things, but like in particular, you'd have linear algebra because you're working in multiple dimensions, calculus because you're going to use hill climbing algorithms that rely on gradients, which use calculus to compute gradients, and then you're going to use probability because the whole point of it all is to calculate the probability of certain things, basically decision making based off of probability, which is artificial intelligence. Data science also, I mean, data science isn't necessarily machine learning and artificial intelligence. However, it's very closely related. Really the only difference is instead of probabilities for decision making, it's just probabilities of events occurring. And that's really the difference between machine learning and artificial intelligence and regular data science. It's kind of all the same. There's just like, you know, a few hop, skip, and a jump away from each other, these things. Although, yeah, I would say, I mean, I don't want to say they're all the same thing. Like, obviously, linear algebra, calculus, and statistics, these are all different. However, they all kind of have relationships to each other. And then they all get combined into fun computations, we'll say. Useful computations. Another thing that's really useful or interesting, I don't know much about it, but it's, I think, control theory. Control theory is very much related to this similar field, and actually I learned recently something in control theory. You can actually implement a solution using neural networks, which are one of the sort of main interesting points of artificial intelligence is neural networks. So, yeah. Anyway, let me stop rambling on here. So yeah, this was an interesting question, and thank you all for watching, hanging out, saying hello. Do appreciate it. I'll talk to you all soon. Have a good rest of your day, a good rest of your night. I got destroyed by this problem. I got owned. I got humbled. I mean, this is why we practice, right? I need to get more humbled. What I learned is I need to be a little more disciplined and a little bit slower about and go through different test cases and think about the problem a little bit, like digest the problem a little bit more. And specifically for problems that I don't really have a good algorithm for, like an algorithm that I've done multiple times before. So something where it's like, you know, walk forward, walk backward, and then jump back, and then scroll forward to the past to where you walked. Something like that is probably going to have some errors in there. You know, there's probably some conditions that I got to consider. So this is something I guess I learned, is that I need to be a little more disciplined, a little more careful, and yeah, not use the submission button as your test cases. That's not the right way to do it. I'd say always a learning experience, always fun, always interesting. But yeah, so thank you again, and I will talk to you all soon. Good night. Yeah, good night. Take care. Take care. Thank you.